Hello folks, welcome back to AG Engineering. Apologies for being away for a little while. Been a little bit busy with some other things going on. I've got a interesting little job on the bench, on the mill, ready to look at. It's a A10 engine that's had an SRM conversion needle roller that needs some work doing on it. It was supplied to me in pieces. The crank plug is absolutely battered, as you'll see in a moment, so the first job is to try and get that one out. We've got to replace the needle roller bearing and check the alignment of everything, and I think also I've got to do the cam bushes. We've got some tight spots on them as well, so a few bits to be getting on with. For all those new people that have joined while we've been off air, welcome. Thank you for your subscriptions. We're over 1,500 now, I think it is, and still growing steadily. Thanks for all the comments from everybody and all the well wishes and everything, but there's no problems. We're not ill or anything, just been a little bit busy with some other things going on. So without further ado, as Bruce Witham would say, I'll take you over to the mill and we'll have a look what we're doing. Hey, if we can see that, this is our issue for today. We've got a plug in there that is absolutely battered. There's nothing to get onto whatsoever, so we've got to try and get that out in the first instance. As you can see, I've got it set up on some rising blocks of wood in this case, and some straps and clamps and various bits going on to hold it steady enough for drilling that out. We're not trying to do precision machining, so the bits of wood hopefully should be okay. I'll just take you around there. You can see through there that the crank is just off the table, just clear, and we've got enough room to get in and do some work on that plug. So I'll get a cutter set up and start pecking away at it to see what we can do with that. I think the plan might be to try and establish where the outside is, because if you can see that, it's been centre punched to death around the edge, so it's very hard to make out what's going on. And we'll try and establish that first, then we'll try and get a hole through it and just tentatively try it with an extractor to see if that'll work in the first instance. If not, we'll have to try some other plans. Right, we've set up in the mill. We'll start with a slot drill and just try and get a flat surface on that plug and see where we are. I've centered it as best I can visually, given the bad edges. That turned out to be a lot harder than I expected with a milling cutter. It wasn't going anywhere, so at the moment I've got a carbide tip drill in there, and it's very slow going, but it is getting there. We'll try and get a hole through it so that I can tentatively try a stud extractor in there. So I'll keep going and bring you back when we're somewhere near. I've just broken through there now. That was pretty tough, the first sort of 50% of that plug weld. I'm not actually sure what it is yet, but when we got halfway through it, as you can see, the chip started getting bigger. So I'll just take the cutter out and I'll have a see what we can drive in there and see if we can turn anything or not. That there is the drill bit I was using. It's a carbide inserted tip twist drill. Looks a little like a masonry bit, but it isn't. It's designed for doing metal, hard metals. I've got a square taper stud extractor in there. I've just tried this a couple of times already, and no, it's not doing anything. I think the plug is too hard on its outer point to outermost bit to do anything. Now it's just taking the edge off the extractor there and not touching that. Right, I think what I may do is just try and continue drilling. I don't know how on centre I am. It was very hard to judge that. It's probably a little bit sort of this way, to be truthful. I'll put it back under and just see what it's like with an ordinary twist drill. Now we've probably got a bit of a surface to get onto. Let's see what happens with that. I've got a 30mm cobalt drill in there, and as you can hear, no, that's not even touching it. It's just bouncing. In fact, it's probably wrecked the drill bit. I've got an indexable milling cutter in here, and this is see what it's doing. That is seriously hard. We've got through with that smaller drill bit. Now we're trying to go through with that 15mm TCT tipped drill bit for metal. That's an Irwin brand one. See how it goes. As you can hear how hard that is to drill. You can see the fine chips coming off it. I honestly have no idea what is in there. It can't be a plug. I'm beginning to think it's weld. They've done it with like a stellite rod or something. I really don't know. I've never come across anything like that before. Let's see how far we can get. Back in a little bit. That's so far. There's a few millimetres to go till the soft part of that plug or whatever it may be yet. I think I've just broke through the bottom of it. You can just about see it there, possibly in the video. So we'll get the drill bit out of the way and see what we've got. Just as a matter of note, I've shortened that drill bit. I took a little bit of the shank off there to fit it in. And I may have been going a little bit slow with that, but I didn't want to go too mad. It's chipped the edge of the drill bit slightly, but that will dress up to go again. Yeah, it's not a masonry bit, it's actually a carbide tip drill bit for drilling steel. That's an Irwin one. There we go, there's our little bits we've got out of there. They've gone magnetic very quickly. Kind of wondering if it's some kind of magnetic plug. Don't know. So I've took them out with a magnetic tool, but they seem quite brittle and magnetic. And there's what we've got so far. Still see the untouched bit of the crankshaft down inside there. So we'll try and get this bit out the side now. I'm just going to have a little tap at it and just see what happens. And say, I don't know if it's actually a screw-in thing or something other. We'll find out. I'm set back up now with the boring head. I've re-centered using the DRO, and we're over the middle of the hole. So I'll bring the table up at this point to there, and I'll just feed the boring head in, and I want to try and just take out the edge of this this piece and see then if we can collapse it in, if there is a thread there to get back onto. So we shall move the boring head along. It's a little bit awkward with the camera in the way. Back off the clamp bolts there. There we go. We'll try and gauge where that's going to start. Unfortunately, I'm clear enough of the tail shaft with the size of the boring head. And I could do this with the automatic one, but I haven't got the indexable cutters for that. I've just got a couple of welded or brazed tip ones. So we'll just take that out to where I can feel it start to nip a little bit. Just take everything up slightly. Take that up, let's see what happens with this. Speed. It's obviously going to be a little bit steady doing it this way. We'll just put about a quarter turn on each time. I'm just going to cut dry till I see what sort of effect I'm having, whether I'm actually cutting or just deflecting. Seems to be cutting. Fortunately we've got a little bit of space behind the plug to actually drop into. Yep, that's cutting. That's all I needed with that 15mm bit, was just to give me enough clearance to get a cutting tool in. I had tried it with an indexable end mill, but it wasn't working with that one. So I knew with a cutting tool we'd be taking sort of light cuts a little bit at a time rather than trying to take a broad cut. But it was just getting in there to start with. I'll carry on like this and bring you back when we're somewhere near. So it'll be the same thing, just over and over again, little bits at a time. It's going, it's working. The more I'm doing this, the bits are sticking to the sides I'm cutting, and as I put a Allen key in there, it sticks to the side. I'm pretty convinced this is a pot magnet or something that's been thrashed into the hole and peened over. That's crazy, because it's not removable to maintain it. I'm pretty sure with the hardness of it and what it is, it's probably neodymium or pot magnet or something like that. We'll keep going until we get to that that little edge there, and then see if it'll break away. And there's a light cut off it again. You can see how the swarf is sticking to the side of the hole. Definitely magnetic. Clumps of material sticking together and sticking to that. I'm hoping when I've got enough of an edge it'll just break away, and I'm getting close now. Okay, I'll just have a little tap at it, and we are indeed moving. Here we go, little broken bits of this very hard material. And get our magnet, hopefully. Yep, we can pull it out. That is what it is. Yeah, that's certainly a new one. And I think behind here, if you can see it or not. I think we've got threads in there. I don't think that's epoxy. I think someone's literally glued a bloody magnet in the crankshaft. In all my years. I don't know, that's a different one. Now this engine has got a conversion for the needle roller and ball thrust, the NKIB bearing. Whether it's an SRM one or someone else's version, I do not know. Is this what SRM do? I've no idea. But at least we have got a thread there, or the start of. Should better run a tap down that. Hopefully they've not machined any of it away, and we can get the original plug back in. But we're not looking too bad in there. Let's just wind this out and take a proper look. When I started off doing this, I was thinking, oh my god, why have I got involved with this one? But I'm feeling a little bit more confident now. Always something new. Let's get a bit of air in that, a bit of cleaner. There we go. So we've still got the oil feed hole down to the crankshaft, which we needed to get to make sure we were clear in that way. For the end feed that has been done, obviously the oil hole comes through. Sorry about the angles. The oil hole normally comes through on the bush, the bronze bush grooves there. This has been this little piece added in and cross drilled through. Then when the bearing sleeve goes on here, it blanks that hole off so the oil feed can go down there through that little plug side into the crank. And you absolutely need to make sure on any rebuild that this is all clear all the way through here. So that's why this plug had to come out. I'll try and find a tap, 7/8 BSP I believe, and we'll see if that thread cleans up. I don't know about getting a start on this, it's a little bit battered around there where they've punched it to death. We've got a little bit of a start on the tap there, past the little punch marks, and it should clean up. Clearance for the camera. Now, knowing what I know now of what it is, and it was a straight sided plug, probably could have got away with a little bit of warming up and tapping it through from the other side of the crank, but we honestly didn't know what it was. About a lot. Just move the camera a minute while I clean this out again. There we are, on retapped hole. The threads survived okay, a little bit battered round the edge, and we've got a new modern plug here when we've got the dipstick, the sump plug tube. Sump plug tube, crankshaft tube, then we shall be good to go with that in there. I think actually there's a plain end and that end, that's probably the other end. I don't remember now, but there we are. We can sort that out in a bit. Okay, we can move on to the next stage of this engine. As I've said, that's been machined down for a NKIB roller and a ball end thrust bearing. So we'll take a look at the crankcases in the next video for this engine. Bye for now.